Okay, guys, today we're talking about radians and how those things deal with this unit circle that we've been looking at. So, radians. What the heck is a radian, you might ask? What does that word look like? Well, maybe you notice that it looks kind of like the word radius. And when I'm talking about the radius of the unit circle, okay, we mentioned that earlier. What is that radius of the unit circle equal to? 1. And that's kind of where the unit circle gets its name, right? 1 unit. So if our radius of the unit circle is 1, let's take that into consideration when we're talking about circumference. So you might need to go back to your geometry days here for a hot second and remember that the circumference of any circle is 2 pi r. So in the case of the unit circle, where our radius equals 1, the circumference of the unit circle is 2 times pi times 1. Or we would really just think of that as 2 pi. So, why does that fit in here? Going over to this circle here on this page. There we go. I'm going to try and center it. We know we start at 0. We talked about that before. Like 0 is 0 degrees. Okay. And one entire lap around the circle would be the circumference. It would be 2 pi radians. So 0 to 2 pi is one lap around the whole circle. If that is an entire circle, think about what that would mean for going from 0 to the halfway point around the circle. So over there on the left side, if one full lap is 2 pi, then half of a lap would be pi. So we would say that that is pi radians when you go that far around the circle. And we can fill in these different radian measures around the circle as we go. So we're going to keep doing some of the easier ones. Going from 0 to pi, the halfway point is up at the top. What is the halfway point between 0 and pi? Well, that would be 1/2 pi. And 1/2 pi we generally write as pi over 2, just as a simplified fraction there. At the very bottom of the circle, this would be the halfway point between pi and 2 pi. So basically it's the halfway point between 1 and 2. And as a fraction, that would be 3/2. But since we're talking about all this pi business, we're going to just call that 3 pi over 2. So that takes care of our first 4 points on the unit circle here. Let's keep going. Looking up in the first quadrant, okay, remember this is called quadrant 1 in the top right corner. Let's go now the halfway point between 0 and pi over 2. So remember, pi over 2 is like 1/2. So the halfway point between 0 and 1/2 would be 1/4. So we can call this one pi over 4, right? 1/4 pi. And similarly over in quadrant 2, the halfway point between pi over 2 and pi, which is really, think of it as halfway point between 1/2 and 1, is 3/4. So that would be 3 pi over 4. Okay. Down to quadrant 3, bottom left corner. Halfway between 1 and 3/2. This is getting a little trickier here dealing with fractions. That halfway point is going to be 5/4. So in radian land, that would be 5 pi over 4. And then over in quadrant 4, the halfway point between 3 pi over 2 and 2 pi is 7 pi over 4. Okay, so far we've got these different radian measures that are pretty easy to land on. Obviously we started with 0, 2 pi, and pi, and we've gone from there. Think about these in terms of degrees though. I started off by saying 0 radians is 0 degrees. That would make 2 pi radians 360 degrees. And at the halfway point around the circle, the pi radians as degrees, that would be 180 degrees. Pi over 2, 90 degrees. And at the bottom of the circle, 3 pi over 2 is 270 degrees. Okay, let's keep filling in these blanks here. Pi over 4, remember that's the halfway point between 0 and pi over 2. You can also think about it, that's halfway between 0 degrees and 90 degrees, 45 degrees. 3 pi over 4 135 degrees. Down to quadrant 3, 5 pi over 4 is 225 degrees. And 7 pi over 4, our last one so far, is 315 degrees. Okay, so far we've hit all these different radian measures that match up with their degree measures. Now we can keep going. If you think back to the first unit circle we did, we also, in each quadrant, had 30 degrees and 60 degrees. Okay. Similarly, in quadrant 2, we also had 120 degrees and 150 degrees. And then in quadrant 3, we also had 210 and 240. And in quadrant 4, we had 300 and 330. Okay. Now we're going to match up the radian measures for each of those, and it's really not so bad. The key thing to all this is thinking about these degree measures. Think about them as fractions, if you will. 180 degrees is pi. So if I'm looking at 30 degrees, I can think about the radian measure there as 30 over 180. As a reduced fraction, that is 1/6. So my radian measure at 30 degrees is 1/6 pi, or pi over 6. My radian measure for 60 degrees, think about that as 60 over 180, which is 1/3. That'll be pi over 3. Now, here's where math is cool. 120 degrees. That is twice as big as 60 degrees. So we're simply going to double the 60 degrees. So double pi over 3 is 2 pi over 3. And think about 150 degrees, the last number here. That is 5 times as big as 30 degrees. So 5 times pi over 6 will be 5 pi over 6. Okay. Let's keep going. 210 degrees. This is 7 pi over 6. 240 degrees. 4 pi over 3. 300 degrees. 5 pi over 3. And 330 degrees is 11 pi over 6. Now I know I'm going through this kind of quickly here, but we'll talk more about how this comes together when we are in class. What I really just want you to see right now is how these radian measures fit around the unit circle. Okay. We'll talk more about the cosine and sine measures as well for each of these. There's more to that in class, so we will look at that together in a little bit. But this is the beginning of the unit circle, at least in radian measures. Okay, great.